Hi, welcome to our pre-calculus. Today's topic is composition of trigonometric functions with variable expressions as input, problem type 2. Very similar to what we did last time, so this table that you see here is what we constructed at the end of the last lecture. You can always use a table or you can use geometry, and that is the preferred way of handling problems that you see here. So let's go ahead and take a quick look at these example problems. So the difference with the problems that we had last time is that you see that the input that is given to you is a fraction. Sometimes a simple fraction, sometimes you see a complicated looking fraction. In either case, the best approach is to draw a triangle that matches your first expression. So what does that mean? What does it mean drawing a triangle that matches this? Well, sine inverse of anything, sine inverse of, in this case, w over 5, always refers to an angle. Let's write it in forward direction, meaning sine of theta is w over 5. Okay, the recommendation is to draw a triangle. So here we draw a triangle and this angle here is theta. Match this to the sides of your triangle and hypotenuse. So sine is supposed to be opposite to hypotenuse. Now, opposite to hypotenuse could be any set of numbers and the ratio will be w over 5, but the best approach is to take just w to be opposite and 5 to be hypotenuse. Of course, we could have made other arrangements as well. Now in this triangle, you want to go ahead and calculate the other side. Just apply the Pythagorean theorem. So it becomes 5 squared minus theta squared. Now look at what is asked. Tangent of, this is the angle theta. So we are asked for tangent of theta. And, well, that's the ratio of the opposite to the adjacent. 5 squared minus, excuse me, I made a mistake here. 5 squared minus w squared. 5 squared minus w squared. And out comes our answer. So you can write that 25 instead of that, and that would be just as fine. So again, we find a triangle that matches our interior expression. We choose the most convenient one. This is so that we avoid haggling with fractions. Of course, you could have applied the so-called triangle from the unit circle, meaning take this to be 1 and this would be straightforward w minus 5. That's fine. Then here you have to write 1 minus w over 5 squared. And then you would write tangent of theta, ratio of opposite to adjacent. That is perfectly fine. And then the thing is to watch out for the fractions and make sure you don't make a mistake in that area. That's the only downside of this thing. So if I multiply numerator and denominator with 5, a 5 disappears from here, and here let's write the 5 times this and a 5 times that. When this 5 goes inside radical, it becomes squared, so I get 5 squared and cancels this 5 and becomes w squared, and then you get the same answer. Just to avoid errors with fractions, we recommend to go about it this way. Let's do another one. Tangent inverse of, so again this is our angle theta. So excuse me, let's see, this whole thing is the angle theta. Theta is tangent inverse of w over 25 minus w squared. So well, that means what? That means tangent of theta is this fraction. So tangent is supposed to be ratio of the opposite to adjacent, and the most comfortable setting that we can have here is to just take the adjacent to be w and adjacent to be 25 minus w squared. If you square these two and add them up and take the square root, you see that the hypotenuse becomes 5. This had to have been 5 so that this becomes this quantity. Well, now what are we looking for? We are looking for cosecant of theta. Cosecant of theta is the ratio of hypotenuse to the opposite. So it all boils down to 5 over w, and that's the problem. This one, again, this whole thing is theta. Theta is tangent inverse of u third. Is tangent of theta is u third. That means opposite is u, adjacent is 3, hypotenuse is 3 squared plus u squared. This is angle theta, and what we are looking for is sine. What is sine of theta? Well, ratio of opposite to hypotenuse. So here we get the answer for that. Okay, well, you have one more. Cosine inverse. So again, this is our angle theta. So theta is cosine inverse of u over radical 9 plus u squared. So it means cosine of theta is that quantity. The easiest way to match this to a triangle is to say this is angle theta, this is my adjacent, and this is the hypotenuse. Well, that tells me the other side had to have been 3. Okay, so of course I square that minus square this. So I take, it's obvious, but just if you wanted to actually show it formally, it's hypotenuse squared minus side squared. Let's call this thing y. That has to be y squared. Well, this is 9 plus u squared minus u squared is equal to y squared. So y, if it is supposed to be positive, will be 3. And then we are calculating cosecant. Cosecant is the ratio of the hypotenuse to opposite. Is that right? Hypotenuse to opposite. If you want to do a complete analysis, you could also go ahead and look at the situation where u is negative. If u is negative, well, your triangle is going to look like this, with this kind of looking obtuse angle, but this side's still 3, and hypotenuse still 9 plus u squared, and sine of that angle would be 3 over radical 9 plus theta squared, and cosecant would be the reciprocal as we had here. So in either case you arrive at the same answer, and there's no other issues with respect to this solution. And so we have covered combination of a function and inverse of some other function. As I mentioned, these things first time around you are going to see it in calculus 2 in a topic that's called integration by trig substitution. So now you're learning it, and perhaps hopefully in 6 months time you are going to actually use it. So until next time, good luck and God bless.